Back in the 80s, it was clear to me that something had to be done. Something better than present day. About safety. And it wasn't only in safety. It was in matters of waste as well, and in proliferation matters, and over all of those things, the matter of economics. You can't make the plant impossibly expensive by making it too complicated.
Let's go ahead and go up to the main parking lot there then.
All right, thanks very much.
So, in 1980, I was given the job of directing the entire program of advanced reactor development at Argonne National Laboratory. Our goal was to design a new type of reactor where the very physics of it would be such that it could withstand almost any type of accident that nuclear plants can be subject to. It was called the IFR, the Integral Fast Reactor. The budget was about $100 million a year. 1,500 people, scientists, engineers, supporting staff. This was a very big development program. But you've got to test it. Calculations don't tell you everything. You've got to have the big facilities that say, if we have an accident of this kind, what will happen?
We will now start setup for the test.
We did 2 experiments to demonstrate some unique safety features that that reactor has that others don't have, and invited people from all over the world to come and witness it.
T-minus 2 minutes.
Station blackout is a term that's used by NRC, the safety folks, to describe the situation where one loses all bulk AC power. You assume that you lose off-site power. You assume that you're getting no AC power from your own turbo generator. You assume that your first diesel started up and it failed to start up. The second one started to start up and it did also fail. So you end up dead in the water with no AC power.
This experiment was almost a direct parallel to what happened at Fukushima. It was eerily similar.
We ran the reactor at full power, disabled the shutdown system, so the operators had no ability to shut the reactor down. And we shut off the cooling system. Didn't extract the heat, so we just let things get hotter. In most reactors, you can't do it. No reactor I know of would survive that accident. You have a meltdown.
The international audience were watching the temperature going up like that, straight up. They turned around like so to see if I was or if the Argonne guys were running. By the time they looked up again, the trace had turned like so, and it was on its way down, and the reactor just quietly shut itself down. No action required of the operators, no action required of the safety systems, nothing. You could just stand back like this, watch the dials if you wished, and the reactor shut itself down.
30 seconds till test time.
Well, in the afternoon, we started the reactor up again and carried out the conditions responsible for the accident at 3 Mile Island.
5, 4.
We shut off the pumps. Just shut off the pumps. All major reactor accidents happen because of one thing: inadequate cooling. The IFR type reactor, which EBR-II was a prototype for, if you cut it off from the steam system so it cannot reject its heat, it will just shut itself down.
So it can't melt down?
No, it can't melt down. We're now in the facility that completes the circle, if you like, of the Integral Fast Reactor. We've come out of the reactor building. We're now in the fuel cycle part. The integral part of it was that every part of a complete nuclear reactor system, not the reactor itself, but also the facilities for treating the spent fuel, for treating the waste, would all be an integral part of the same system. What this enables you to do is you can take the spent fuel, chop it up, and back it goes into the reactor again. You can recycle the fuel again and again until the end of plant life. The other thing needs to be said about all of this technology is that this is not a dream. This is not somebody's calculations on a piece of paper. This is real. We know how to do these things.
Now let me frame this debate, if I may, by reading a letter from the President of the United States sent to me yesterday. Thank you for your letter supporting our decision to terminate the Department of Energy's Advanced Liquid Metal Reactor program, including the Integral Fast Reactor. I want to assure you that this administration does not support the IFR and will oppose any efforts to continue the funding for this reactor project.
Democrats have gotten themselves on the wrong side, in my opinion, in this issue, being opposed to nuclear power for, I think, no good reason other than that it's very high on the list of what Republicans like.
We know that nuclear energy is clean. We know that it doesn't pollute the air. We know that it doesn't damage the ozone. We know that it is a tremendous producer of energy in a clean sense, and our only problem is that we cannot come to political terms on how to handle the waste stream.
We're talking about what it's going to cost if we go that far and continue our obsession with nuclear power.
IFR waste streams lose their radioactivity to background level in about 800 years. Light water reactor in nearly 10,000.
I share with my colleagues some of the public opinion on this. The Washington Post, the wrong reactor, the Oregonian, give up nuclear breeder dream, the San Francisco Chronicle, saying no to nuclear pork.
The IFR program was shut down, and the project went down the black hole of government politics.